Let's start at the very beginning, 1917. The United States enters the First World War without a single domestically produced tank. Not one. The trench warfare killing fields of Europe had already proven one brutal truth. If you wanted to cross no man's land and survive, you needed armor. The British and French had figured that out. America hadn't. The M1917 was America's answer, a direct copy of the French Renault FT-17, built under license on American soil. It was a small two-man machine with a fully rotating turret, which sounds basic now, but was genuinely revolutionary in 1917. A 37mm gun, top speed of 5.5 miles per hour, thin armor. The whole thing weighed 6 tons. 950 were built. None of them made it to the front before the armistice was signed in November 1918. The war ended before America's first tank ever fired a shot in anger. The Ford Model 1918 was a different idea entirely. Henry Ford wanted to flood the battlefield with cheap, fast, mass-produced tankettes, 3 tons, 2 men, built from Model T parts. On paper, it was genius. In reality, it was a disaster. Twin engines crammed into a tiny hull meant the crew was breathing exhaust fumes in an enclosed steel box. It topped out at 8 miles per hour. 15 were built. The project was quietly abandoned. The Tank Mark 8, called the Liberty Tank, was America's collaboration with Britain for the big breakthrough push. 11 crew members, 39 tons, 2 6-pounder guns, built to cross the massive trench networks of the Hindenburg Line. It entered service in 1919. The war had been over for months. 125 were made and immediately rendered obsolete. That's the cruelest kind of engineering, perfect for a fight that's already finished. Up next are the interwar designs, and this era is stranger than it sounds. After WWI, the U.S. Army legally banned anyone except the infantry from developing tanks. The cavalry wanted armored vehicles too, but the law said tanks were for infantry only. So the cavalry did something clever. They called their tanks combat cars instead. Same vehicle, different name. Problem solved, bureaucratically speaking. The M1 combat car came out of this workaround in the mid-1930s. 10 tons. A Continental R670 radial aircraft engine ripped straight from aviation, and a vertical volute spring suspension that let it hit 45 miles per hour on roads. 45. That's faster than some modern cars in city traffic. But here's the problem. It had no cannon, just .50 and .30 caliber machine guns. Then the Spanish Civil War happened. Tank versus tank fighting proved that machine guns do nothing to armored vehicles. The combat car was already obsolete before it was fully fielded. The M2 medium tank followed in 1940, and it arrived just in time to watch Germany's panzer divisions tear through France in 6 weeks. The M2 had a 37mm gun, multiple machine guns, and a silhouette taller than it needed to be. It was outclassed before it ever reached a battlefield. But here's what mattered. Building it forced American factories to develop the engine supply chains, the suspension systems, and the production tooling that would later build the Sherman. The M2 medium didn't win any battles. It built the infrastructure that won the war. Now shifting to the World War II light tanks, the fast movers, the scouts, the machines that kept Allied commanders informed and enemy flanks exposed. The M3 Stuart entered service in 1941 and became one of the most important vehicles of the war, not because it was the most powerful, but because it worked. Every single time. A 37mm gun, 36 miles per hour, top speed, 100-mile range, over 22,000 built. The British used it so extensively in North Africa that their crews gave it a nickname. They called it the Honey, because driving it felt that smooth compared to what they'd had before. It was eventually outgunned by heavier German armor, but as a reconnaissance platform, it remained invaluable through the entire war. The M5 Stuart followed in 1942, replacing a single engine with twin Cadillac 5.8s and adding sloped armor to the hull for better protection. It kept the 37mm gun, still a weakness, but the improved powertrain and survivability made it a reliable upgrade. Where the M3 had been rugged, the M5 was refined. By 1944, the Army knew it needed more firepower in a light package. The answer was the M24 Chaffee. Engineers took a 75mm aircraft cannon, stripped it down, and fitted it to a light tank chassis with a modern torsion bar suspension. The result could hit 35 miles per hour and actually threaten enemy armor. Armor was still thin, maxing out at 38mm. But the Chaffee represented a genuine leap in what a light tank could do. It replaced the Stuart in the reconnaissance role and stayed in service with Allied armies for decades after the war. The M22 Locust was built for one specific mission: fly into battle inside a glider, land behind enemy lines, and provide armored support to paratroopers who had none. 3 tons, a 37mm gun, fragile construction. It worked as an engineering concept. It could actually fit inside a Hamilcar glider, but in combat it was dangerously underprotected. The idea was sound. The execution rarely survived contact with reality. Another key group, the medium tanks. These were the backbone of the Allied armored effort, the machines that carried the fight from North Africa to Berlin. The M3 Lee was a stopgap, and everyone knew it. When Germany's panzers rolled into France with 75mm guns and America had nothing to match them, engineers did something ugly but practical. They bolted a 75mm gun into the side of the hull, where it could only rotate about 15 degrees. A separate 37mm gun sat in the turret above. The whole thing stood nearly 10 feet tall. British crews in North Africa called it the Grant in their modified version, and they used it because they had no choice. It was cumbersome, highly visible, and tactically limited. But it put a 75mm gun on the battlefield while America retooled for something better. The M4 Sherman is the tank that defined American armored warfare in World War II, not because it was the best tank on the field, but because there were so many of them. Over 50,000 Shermans were built. The Army designed it to fit inside the dimensional limits of naval transport cranes and ship holds, so it could be shipped anywhere in the world and maintained with a common set of parts. Different variants ran on different engines: radials, V8s, twin diesels, even a Chrysler multibank that was essentially 5-car engines bolted together, because the goal was to never let a supply shortage stop production. When heavier German tanks appeared, the Sherman got upgraded. The M4A3 76W added a high-velocity 76mm gun and wet ammunition storage to stop the catastrophic fires that had killed so many crews. The M4A3E8, the Easy 8, got a new horizontal volute suspension that vastly improved cross-country performance. The M4A3E2 Jumbo added heavy armor for breaching fortified positions. The British fitted their Firefly variant with a 17-pounder gun that could actually kill a Tiger. The Sherman wasn't always the best tank in any particular engagement, but across the whole war, across every theater, it was the right tank, because it was everywhere, all the time, every day. The M26 Pershing arrived in 1945 and changed the equation: a 90mm main gun, heavy cast armor. Finally something that could face a Panther or Tiger on equal terms. The problem was the engine. It was the same 4G AAV8 used in the lighter Sherman, now hauling 47 tons. The Pershing was sluggish and its transmission was notoriously unreliable, but when crews got it into position and lined up that 90mm gun, nothing the Germans had could feel safe. It arrived late. It still mattered. We now turn to the Pacific, where the enemy wasn't across a muddy field, but across miles of open ocean and coral reef. The LVTA-1 was the Marine Corps' answer to a specific and brutal problem. How do you provide armored fire support to troops landing on a beach with no cover while still crossing the surf zone? The LVT, Landing Vehicle Tract, started life as a swamp rescue vehicle. The Marines looked at it and saw something more. They mounted a 37mm Stuart turret on top, gave it torso-elastic suspension, and sent it into the water. It could do 7 miles per hour at sea, 25 miles per hour on land. At Tarawa, Saipan, and Iwo Jima, these machines waded in under fire to give Marines something they desperately needed: direct fire support before the beach was secured. The LVTA-4 upgraded the armament to a 75mm howitzer turret, the same gun used in some Sherman variants, delivering heavier, high-explosive fire against hardened Japanese defensive positions. Still lightly armored, still vulnerable. But in the Pacific Island campaigns, nothing else could do what it did. Now shifting to the Cold War Patton series, a generation of tanks built to face a new enemy across a new kind of front line. The war ended. The Soviet Union didn't. When IS-3 heavy tanks rolled through Berlin's Victory Parade in 1945, American officers in the crowd realized their M26 Pershings were already outclassed. Then Korea erupted in 1950, and U.S. forces found themselves fielding Shermans against Soviet T-3485s. The M46 Patton was the Army's immediate fix. Take the M26 Pershing, Drop in a new Continental AV1790V12 engine and a CD850 cross-drive transmission, and transform a sluggish tank into something fast and reliable. It worked. In Korea, the M46 dominated every tank engagement it entered, but it was always meant to be temporary. The M47 Patton came next, a marriage of the M46 hull with a new turret from the T-42 prototype. It carried a 90mm gun and, for the first time on any production tank, a stereoscopic optical rangefinder. Gunners could now calculate distance to target with a precision that simply hadn't existed before. The U.S. Army treated it as a stopgap, but it was exported widely, to NATO allies, to Pakistan, to Jordan, where it fought in conflicts from the Indo-Pakistani Wars to the Middle East for decades. The M48 Patton was America's first real clean-sheet tank design since the war. A hemispherical cast turret, an elliptical hull, an electromechanical ballistic computer. Crew reduced to 4. Everything about its shape was designed to deflect incoming rounds rather than just absorb them. Early versions had a serious flaw: gasoline engines that gave a range of barely 70 miles before the tank ran dry. Later variants fixed that with diesel engines. And the M48A5 upgraded the main gun from 90mm to 105mm. It fought in Vietnam. It fought in the Middle East, and it's still in service with some nations today. Another key group, the heavy tanks. These were America's attempt to outarmor the Soviets at their own game. The T-28 Super Heavy tank was designed during World War II to crack the Siegfried Line, Germany's fortified western defensive wall. 12 inches of frontal armor, 95 tons. Double-width tracks to keep it from sinking into the ground under its own weight. It could take hits that would vaporize any other vehicle. It could also barely move, 8 miles per hour on a good day. By the time it was ready, Germany had surrendered. 2 prototypes were built. One was found abandoned in a field in Virginia in 1974, where it had apparently sat forgotten for decades. The M103 heavy tank entered service in 1957, America's answer to the Soviet IS-3 and T-10 heavies. A 120mm rifled cannon firing separate loading ammunition so large it required 2 dedicated loaders and a 5-man crew. The gun could punch through anything the Soviets fielded at ranges they couldn't match. But it was slow, 21 miles per hour, and its initial range was a painful 80 miles. More damaging was the shift in warfare itself. As shape-charge warheads advanced, thick steel armor stopped being a reliable defense. By 1963, the Army disbanded its heavy tank battalions entirely. The age of the heavy tank in American doctrine was over. We now turn to the M60 series, the tanks that bridged the Cold War, combining the firepower of a heavy with the mobility of a medium into one platform called the main battle tank. The M60 entered service in 1960, visually similar to the M48 but fundamentally different underneath. A British-designed 105mm L7 rifled gun, a more powerful diesel engine, and a straight-sloped glacis plate. Over 15,000 were built. It became the standard tank for the U.S. military and dozens of allies. Not flashy. Not revolutionary, just dependable, lethal, and everywhere. The M60A2 was a different story. Nicknamed the Starship by its crews, not as a compliment. It replaced the standard gun with a 152mm launcher capable of firing both conventional shells and the MGM-51 Shalala anti-tank guided missile. The concept: engage Soviet tanks at ranges far beyond conventional gun effectiveness. The reality: the electronics were fragile, the missile system was maintenance-intensive, and combustible casing residue kept fouling the breech. It was withdrawn from service not long after introduction. The Starship never really flew. The M60A3 was where the platform finally reached its potential. A tank thermal sight and laser rangefinder gave crews the ability to see and engage targets in complete darkness, something that simply hadn't existed before at scale. It wasn't a new tank, it was an old tank finally given the eyes it always needed. Another key group, Cold War light tanks built for the Army's rapid deployment and airborne forces who needed armor. They could actually move by air. The M41 Walker Bulldog replaced the Chaffee in 1951. A high-velocity 76mm gun, a fast and agile chassis, 45 miles per hour on roads. But it was too heavy for practical airdrop, consumed fuel at a brutal rate, and the Army needed something lighter. It was widely exported and fought in Vietnam, South America, and Asia long after U.S. service ended. The M551. Sheridan was the most radical American light tank ever fielded. Aluminum hull to save weight, 15 tons. Parachute deliverable from a C-130, and it carried a 152mm gun/launcher, the same concept as the M60A2 Starship, capable of firing both conventional rounds and Shalala missiles. In Vietnam, crews found the 152mm devastating against bunkers and personnel, but the aluminum armor couldn't stop heavy machine gun fire or mines. The missile system rarely worked as intended in jungle heat and humidity. The Sheridan was a machine of extremes, extraordinary firepower, extreme vulnerability. It served until 1996 and was the last American light tank until the M10. Now shifting to the modern era, where one tank came to define American armor completely. The M1 Abrams entered service in 1980 and represented a fundamental rethinking of what a tank could be. Gone was the steel-only armor philosophy. In its place, Chobham composite armor, layers of steel, ceramic, and advanced materials that absorbed and deflected shape-charge warheads in ways solid steel never could. Gone was hydraulic fluid in the turret, replaced with electric systems to eliminate the fire risk. And at the heart of it all, a Honeywell AGT 1500 gas turbine engine. Not a diesel, not a gasoline piston engine, a turbine, like a jet aircraft. It gave the 60-ton Abrams the acceleration of a sports car. It also consumed fuel at a punishing rate and needed a massive logistical tail to keep running. But the trade-off was worth it. Nothing on the battlefield moved like an Abrams. The M1A1 Abrams, introduced in 1985, added the weapon that made it lethal at any range, the Rheinmetall 120mm M256 smoothbore cannon, built under license from Germany. It fired armor-piercing, fin-stabilized discarding Sabat rounds with depleted uranium penetrators, the densest, hardest penetrators ever put in an American gun. In the 1991 Gulf War, M1A1 crews destroyed Iraqi T-72s at ranges exceeding 3,000 meters, beyond the visual range of the enemy. In one engagement after another, the Abrams took hits that would have killed anything else and kept fighting. The Gulf War wasn't a test of the Abrams, it was a demonstration. The M1A2 SEPV3 is the current fielded standard, and it bears only a surface resemblance to the original 1980 M1. A commander's independent thermal viewer lets the commander and gunner track separate targets simultaneously. Third-generation thermal sights, digital networking that ties the tank into a broader battlefield information system, explosive reactive armor kits for urban combat, active protection systems to defeat incoming missiles. The weight has grown to nearly 74 tons, straining bridges, straining logistics, straining the recovery vehicles that have to pull it when it breaks. In 2023, the Army canceled the planned next upgrade package, acknowledging something significant. Adding more passive armor wasn't going to solve the new threats: loitering munitions, top attack drones, first-person view kamikaze strikes that were reshaping tank warfare in Ukraine. The next step for the Abrams is the M1E3, designed from the ground up to be lighter, modular, and drone-resistant. Prototypes appeared in early 2026. The Stryker M1128 mobile gun system tried to put a 105mm gun on wheels, an 8x8 wheeled chassis that could be airlifted and deployed rapidly. For the global war on terror, fast and mobile mattered more than heavy. The autoloader that made the gun work without extra crew turned out to be maintenance-intensive and failure-prone. The flat-bottomed hull was dangerously vulnerable to IEDs. By 2022, the Army retired every M1128 in its inventory. The wheeled direct-fire concept didn't survive. The M10 Booker was the Army's most recent attempt to give infantry units a dedicated direct-fire support vehicle, 42 tons, a 105mm M35 rifled gun, a 4-man crew, an MTU diesel providing 800 horsepower. Officially, the Army called it a combat vehicle rather than a light tank, partly for doctrinal reasons, partly to avoid budget fights. In practice, it functioned as a light tank, capable of accessing terrain the Abrams couldn't reach, supporting dismounted infantry with cannon fire, and providing organic firepower to brigades that had none. First deliveries came in 2024. The program was canceled in 2025 after limited production, caught between budget pressures and shifting strategic priorities. The Booker is gone. The need it was built to fill is not.